Hello everyone, so we're going to talk about the results of the May 31st outdoor experiment that we did using the declination dial, the horizontal sundial, the flat equatorial dial to measure the shadow angles, and even the regular equatorial dial that was angled at 55 degrees. So I'm going to go in each time period and go through this. I may have to do two parts because it is kind of lengthy. So let's get started. Okay, so I did videos of these and uploaded these yesterday on the 31st to show that I was doing this in real time. And so those videos will help correlate with all of the data that I'm showing here. So what I'm doing here is I'm essentially putting the sphere, the Earth, globe Earth, at the position where it is relative to the sun. So the light is sitting at 159. That means 159 days after December 21st. Okay, so December 21st, or you can say 180 days minus from June 21st to May 31st as well. So whatever that day is, it's going to be at 159. So that right there is the position of the sun relative to the Earth. So at day 159. And so what I've done here is I've put where the sun is, or where the Earth is in its rotation relative to the hours. So I try to do it around the solar noon times, which was 1:04 p.m. So all of the hour marks, I tried to get as close to the 04 p.m. time. So 9:04, 10:04, 11:04, 12:04, 1:04, 2:04, 3:04, and 5:04. Some of them were a little off, and I will explain which ones that were off by a few days, or excuse me, by a few minutes, and then go from there. So what we're going to do here is look at the side-by-side comparison of what we saw in reality versus what the globe model predicted. So we have, let's start with the easiest ones. So we have the horizontal sundial, which is pretty easy to see. And we're going to look at it side by side. So horizontal sundial, you can see there's middle, there's 1, 2, 3, 4 hours before solar noon. Okay, so you can see that right there. Again, 1, 2, 3, 4 hours before, which is at 9:04 a.m. And our photograph here at 9:04, or actually around 9:06 a.m., matches what the globe model predicts. So this matches. So then we're going to do the equatorial flat dial, which shows where the shadow angle would be. And we see that the shadow angle is here. Okay. And so the equatorial flat sundial is showing here as well. So let's kind of zoom in so we can kind of see it side by side. And when we look at it, right, you see that this is 90 degrees off of that, and it's just below that, or just below the 270 degree heading, if you were to look at it in a compass perspective. So right below that line, and we see here, it's doing the exact same thing. So this is actually a digital representation of this physical piece right here. So you can see that the distances and everything line up just right. So this matches this. So we're going to go and look at the declination dial. So here is the declination dial prediction on the globe model. And here is the declination dial as we observe it in reality. So you see how where it's almost a little bit shy of 90 degrees, a little bit downward off of 90. And then when we look at this one here, if I can get it close enough, it is also a little bit down off of 90. So when you look at them side by side, they match. So we have three measurement tools that were used at the same time, and they all matched the around 9:04 to 9:06 time frame. So now we move to the 112 marker, and this is going to be at right between 10:04 and 10:08. And so here is what the glow prediction is showing, and here is what our photograph evidence is showing at that time period. So the horizontal sundials match. So now let's switch over to the equatorial flat and look at what is happening with the equatorial flat. So the equatorial flat, if we can see if we can get it, I don't know how close we can get it, but the equatorial flat is showing a little bit above 90 and pretty short. And so side-by-side comparison, this is actually also showing just above 90 and a little bit short. So these two, reality matches their prediction. So we can go now to the equatorial, which is going to be new for this hour, but it does the same thing as the horizontal. It's 1 to 3 hours, and the showing here 1 to at the 3rd hour there. So the equatorials also match. And lastly, we are going to show the declination dial. I can get it at a good angle. So here's our declination dial at this position. And let's see what our declination dial is showing here. So there you go. So the declination dial is just a little bit above 90 perpendicular, a little bit above 90 perpendicular. So these two, reality, prediction, matches. All right, we may not have time to do all of them, so we'll just try to work on the morning ones. So we're at 11:04 a.m. here. This is the glow prediction for 11:04 a.m. We're 2 markers off of solar noon, and we have 2 markers off of solar noon. So the observed reality matches the glow prediction. So now let's jump to the equatorial flat dial. So it's going, let's see, we're 90. So it's 15 degrees above that 90, just a little bit in the glow prediction. So we're looking at right here. We're having the same thing. So we're at here, and we're just a little bit above that line right there, as we show in there. And so the distances also match. Now let's switch over to the regular equatorial. The equatorial, of course, is going 2 hours off, and that usually doesn't have an issue there. And so we're seeing the same thing here, 2 hours off. So we have that line, and that line both matches. And what's really interesting is that and that also matches. So these matching the glow predictions. So now let's go to our declination line for this time period, and let's scroll down and look at the declination line here as well. And these both match reality and the glow prediction. So this is at around 11:04, 11:05 a.m. All right, we're going to try to squeeze in one more real quick. So this is the 12:04, and here is the 12:04 photo. Just 1 hour right before solar noon, 1 hour right before solar noon. We're going to go to the equatorial flat, show that, and show that side by side, matching. Then we're going to show the regular equatorial, showing it 1 hour, and showing it at 1 hour. So now we're going to do the analemma, or excuse me, the sun declination. And they both match. So here is 9:04 to 12:04 on March 31st, 2025. All 4 tools match observed reality with the glow predictions.